Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into another section here in our Algebra 1 class here. This is Unit 2, all right, Unit 2, Section 3, and in the book it corresponds to Section 5.3 in the textbook here. So if you want to refer to that for more examples, be my guest, okay? We're going to get into a simple activity here, how to graph a linear function in slope-intercept form. And we're talking about slope-intercept form, or y equals mx plus b. Okay, it's a first degree linear equation. We're going to take a look at how to plot this equation, not by using the slope and the y-intercept, but by plotting points and then make connections with the slope and the y-intercept here. All right, so get your pencil out, ruler too, all right, so we can graph it nicely, and then we'll get started, okay? So here we go. What we need to do, if we're going to do this by plotting points, is we need to figure out what points lie on this line and satisfy this equation. So what you do is you start with the domain, okay? You pick an appropriate domain. Now, domain is a fancy word for the set of all possible x values. All right, so let's write that down. Domain, all right, set of all possible x values. Set of all, keyword all, possible x values. And when you plot points, you have to pick appropriate domain so you can plot them on the graph here. Now, knowing that x is being multiplied by 1/2 and then adding 3, uh, you might want to pick multiples of 2 because you're going to have to take half of each one. So to avoid fractions and to plot the points easily, pick the appropriate domain. I mean, you always pick negatives and positives. So typically we go from -3 to +3 here in the domain. However, to avoid fractions, to make our arithmetic simple, all right, I'm going to pick multiples of 2 because I'm going to have to take half of them. And I know that half of an even number, or half of any multiple of 2, is easy to work with. So always pick some negatives and positives. So I'm going to go from, let's say, -4, because my graph's kind of small here, and look at the scale. It goes from -4 to 4, actually -5 to 5. So if I pick a domain that are multiples of 2, then it'll be easy to work with. So -4, -2, 0, 2, and 4. And what we want to do is substitute them into the function. Okay, it's going to be 1/2 times that value, and then add 3. That's what every y value is. In fact, let me write that down. It's equal to 1/2, all right, 1/2 times whatever x is, and then add 3 more. So I need to substitute it in right here, okay? So for -4, y is equal to 1/2 times -4, and then add 3. What is that? Well, half of something is the same number divided by 2. Okay, when you take a half of something, you divide it by 2. So -4 divided by 2, okay, is -2. All right, -2 plus 3 is 1. Okay, so you divide it by 2 first. -4 divided by 2 is -2. -2 plus 3 is +1. Okay, likewise, when you take 1/2 of -2 and then you add 3, what do you get? Well, half of -2 is -1, plus 3 is 2. All right, you divide first. -2 divided by 2 is -1. -1 plus 3 is 2. When you substitute 0 in, you got it. Whoops. You got to take 1/2 times 0 and then add 3. Well, these cancel, right? Anything times 0 is 0. And you add 3 to it, you get 3. So when x is 2, you get 1/2 times 2 plus 3. It's always a half of something plus 3 more. That's what this function is all about. 1/2 of 2 is 1, plus 3 is 4. And there's a pattern here. The change in y is 1. So I expect here. Okay, that's if we keep the x values increasing by 2, that is, okay? And then half times 4 plus 3. Well, half of 4 is 2, right? 1/2 times 4 is 2. 2 plus 3 is 5. So I've got 5 ordered pairs here, so I got to plot them. Okay, so you plot the points. Switch to red here so you can see it on the screen easily here. And let me see, -4 comma 1. That's left 4 up 1. Okay, left 4 up 1. And then -2 comma 2. Well, that's left 2 up 2. So left 2 up 2. 0 comma 3 is simply up 3. Okay, 2 comma 4 is right 2 up 4. Right 2, 1, 2, 1, 2, 3, 4. And then 4 comma 5 is right 4 up 5. Okay, and then use a straight edge, use a ruler here. Use a ruler, there you go, or a straight edge to graph your line, okay? And I've got some digital tools, so I'm going to use this one here. So, okay, so draw your line. And you'll notice that the slope right here is 1/2. From point to point, you go up 1, right 2. Rise over run, right? Rise divided by run. So the slope here is 1/2. Okay, you'll see that here in the equation too. Slope is 1/2. And the y-intercept is right here. It's where the line crosses or meets the y-axis. So let's write that down too. It's where the line intersects or meets or crosses, however you want to say it, but in mathematics we say intersect, okay, the y-axis. Okay, that's the y-intercept. Okay, it's a very special point. Now you can see it in the, you can see it right here. There's your y-intercept. All right, you also see it in the equation right here. It's 3. Okay, it's 3 on the graph, and it's also 3 in the equation. Sorry about that, guys. I'm at school. Okay, so there you go. So you pick appropriate domain, which is your set of x values. You substitute it in your function and evaluate it using the order of operations. Okay. You verify the slope on your graph. It's easy. From point to point, you go up 1, right 2, up 1, right 2, up 1, right 2. You step it out, and so you can see the slope on the graph. Okay, this is your slope. All right, you can also see the y-intercept on your graph. So this constant in the function represents the y-intercept, and your coefficient of x represents your slope. Okay, and you probably knew that from last year in middle school. So there we go. And so what you need to do is just pick an appropriate domain for each function to make your arithmetic easy. All right, let's try another one. Now this next function here is -1/3 x plus 2. All right, y equals -1/3 x. So your slope here, I can already see it as -1/3, and your y-intercept is 2. All right, but we're going to pick appropriate domain, knowing that we have to multiply it by -1/3, or we have to divide each x value by 3. Divide each x value by 3. Knowing that, I'm going to pick multiples of 3 because it makes sense doing the arithmetic. Although you don't have to. You can go from -3 to +3 if you like. So let's pick, let's start with, let me see, -6 is off the graph. Can't do that one. So let's start off with -3, and then we'll go to 0, 3, and then we'll go to 6, even though it's going to be slightly off the grid. All right, because you notice that my grid stops at 5. All right, but we're going to do it anyway. So it's -1/3, all right, times whatever x is, plus 2 this time, okay? And we have to substitute each x value right here where you see x. So substituting in first, we get -1/3 times -3 plus 2. You always simplify first, okay? And when you multiply something by 1/3, you divide it by 3. And notice that the negatives cancel out first because the negative times the negative is a positive. And then the 3 divided by 3 is 1. And then when you add 1 to 2, you get 3 here. So that's a point on the graph. -3, 3 is a point on the graph. We can actually plot that. So left 3 and then up 3. There's your point on the graph. Okay, and then next one, -1/3 times 0 plus 2. Well, anything times 0 is 0. Boom, it's gone. And you just get 2. Why? Because 0 plus 2 is 2. Okay. And then -1/3 times 3 plus 2. Okay. So here this is going to be a -1 because the 3 divided by 3 is 1, but multiplied by -1 is -1. And -1 plus 2, well, that's just 1. And there's a pattern here. Just look at the patterns. And -1/3 times 6 plus 2. Well, let me see. 6 divided by 3 is 2, times -1 is -2. -2 plus 2 is 0. Okay, these are points on the graph. So let's plot them. Okay, -3, 3 is right here. Left 3, up 3. 0, 2 is just simply up 2. 3, 1 is right 3, up 1. And then 6 comma 0 is, there's 5, and then so there's 6. There's 6 comma 0. So take your straight edge out, and then connect the points. All right, and so you can see your slope. You're going to go down 1, right 3, down 1, right 3, down 1, right 3. So you can see the slope is negative 1/3. That's rise over run. Okay, the y-intercept, you can see where it crosses the y-axis here at 2. So label the y-intercept on the graph and label it as 2 or 0, 2. Okay, and there you go. So you just pick an appropriate domain here. Okay, this set of y values is called range. So you pick appropriate domain, evaluate the function. Okay, you substitute x into the function, evaluate it using the order of operations, you get the range, and then once you know that, you got at least 2 points, because you need at least 2 points to plot a line, and you graph, and then you make sure that you identify your slope properly. Okay, you can see the slope in the function also in the graph, and then make sure you identify the y-intercept in the graph. Okay, now here there's no fraction. Okay, y equals negative x plus 1. This is the same thing as y equals, whoops, hang on guys, getting a little crazy here. Y equals a negative of whatever x is plus 1. Y equals negative of whatever x is plus 1. So I got to substitute x in to my variable. All right, and then make it negative and then add 1. So this is very simple. So let's just go from -4 to, I don't know. See how much room we got here. We'll just do one at a time. So y equals a negative of a -4 plus 1. Okay, well, a negative of a negative is positive, so they cancel. And then 4 plus 1 is 5. Oh, sorry about the bell, guys. So 4 plus 1 is 5. And then you keep on going. So you take a negative of a -3 plus 1. Each time you see the double negative, cancel it out. 3 plus 1 is 4. When x is -2, you get negative of a -2 plus 1. Cancel out the double negatives. All right, 2 plus 1 is 3, and there's a pattern here. Right, 5, 4, 3, right, 2, 1, right? If you just keep going using the pattern. So negative of a -1 plus 1. Cancel out the negatives. And then evaluate. 1 plus 1 is 2. Okay, and then the last one, negative of a 0 plus 1. Well, that's 0 plus 1 or 1. All right, so then you plot the points. So left 4 of 5. So left 4 of 5. -3 comma 4 is left 3 of 4. Left 3 of 4. You're just a counting exercise. -2 comma 3 is left 2 up 3. And then -1 comma 2 is left 1 and then up 2. So left 1 up 2. And then 0 comma 1 is just simply up 1. All right, and then you graph your line from there. It's that simple. Okay, and then you could see the slope. Okay, you go down 1, right 1. That's a slope of -1. You can see the y-intercept right here. Okay, at 1, at 0 comma 1. Okay, this right here, the highlights highlight the y-intercept. There's your y-intercept right there at 0 comma 1. And your slope is -1. You can see it on the graph. You can see it right here. Okay, there's your slope. So the slope is -1. Remember, slope is a coefficient. It's a number. It's not a variable. Okay. Now, if you want to pause and play the video here, you can. Okay. You can pause it right now and try it. And then when you're done, you can play it. So you can do a little pause and play action. All right. And remember, just pick an appropriate domain. Like there's no fraction here. So you can go from -4 to +4 because we have that much room on the graph. So -4 all the way to +4. So -4, -3, -2, 1, -1, 0, 1, and 2. You can substitute them in. All right. And y is going to be 2 times that value minus 2 this time. So 2 times -4 minus 2. That's -8 minus 2 or -10. 2 times -3 minus 2. That's -6. Minus 2 is -8. 2 times -2 minus 2 is -4 minus 2, or -6. Look at the patterns here. You know, the range here is increasing by 2. Negative, you're adding 2 here each time. There's a pattern. And then right here, this is 2 times -1 minus 2. That's -2 minus 2, or -4. 2 times 0 minus 2 is just -2. 2 times 1 minus 2, that's 0. 2 times 2 minus 2, that's 4 minus 2, or 2. Now here, these points right here, the first 3 points are going to be off the graph. So when I'm looking at my range right here, since these are off the graph, okay, I don't have to plot these. I can plot these points. Okay, so you need at least 2 points to plot a line. You need at least 2 to plot the line. So let's highlight that. So whatever you do, you got to have at least 2. So we're going to plot from here down. So -1 comma -4. So -1, that's left 1, down 4. 0 comma -2 is right here. It's just down 2. 1 comma 0 is 1 to the right. And then 2 comma 2 is right 2 up 2. And then from there, graph the line. Okay, and from there you can identify the slope. So it's up 2, right 1. And that's a slope of 2 over 1, or 2. Remember, it's rise divided by run. You could also see it here in the equation right here. There's your slope. You can see the y-intercept in the equation. It's right here. Okay, the y-intercept is at -2, or what's called 0 comma -2. All right, you can see that in the equation. It's right here, -2. So you can see it in the function. You can also see it in the graph itself. Okay. All right, once again, you could be pausing and playing here on the video if you like. On number 5 here, if you want to pause it right now and go for it, and then play it when you're ready, go for it. Keep in mind though, all right, you have to take 5/2 times something. And knowing that you have to divide whatever x is by 2, you might want to pick multiples of 2, just to make the arithmetic easy. All right, multiples of 2. What does that mean? Well, a -4, -2, 0, 2, and 4. That's what it means. Multiples of 2. It's numbers that are divisible by 2. Okay, so here we go. Pause it if you like, or just let it run. Okay, it's totally up to you guys. So I got to take 5/2, all right, times whatever x is, and then -3. Okay, that's what this means. 5/2 times x, and then -3. So I got to substitute my x value right here. Okay, so here we go. So we're going to take 5/2 times -4, and then -3. So you divide it, always divide first, it's easier. So -4 divided by 2 is -2. -2 times 5 is -10. -3 is -13. Always divide first. -2 divided by 2 is -1, times 5 is -5, and -5 minus 3 is -8. Okay, 5/2 times 0, -3. Well, these just cancel out, right? -3 is a -3. And then 5/2 times 2, -3. The 2's cancel. 5 times 1 is 5, -3 is 2. Look, there's a pattern here. +5, +5, +5. The pattern here is +5. Okay, that's your change in y. All right, change in x is 2. And change in y divided by change in x, guess what that is? It's slope, and it's 5/2. Okay, the slope here is 5/2. All right, so 5/2 times 4 minus 3. Always divide first. 4 divided by 2 is 2. 2 times 5 is 10. 10 minus 3 is 7. Okay, now you can't plot the first 2 points because -13 and -8 are off the grid. All right, so what I'm going to do is I'm going to plot only these. Okay, and as I said before, you need at least 2 points. So let's plot the first order pair. Let's plot 0, -3. Now, 0, -3 is down here. That's your y-intercept. 2 comma 2 is right 2 up 2, it's here. And then 4 comma 7 is kind of off the grid. So right 4 up 7. 1, 2, 3, 4, 5, 6, 7. It's right here. Okay, so we can plot those and then take your straight edge out and graph. You can see the slope here from point to point. You go up 5 and then right 2. There's your slope. All right, your y-intercept is right here. Okay, and there's your y-intercept at -3 or 0, -3. And like I said earlier, the slope is 5/2. Slope's here, y-intercept's here. And that, my friends, is how you do it. You got to learn how to pick an appropriate domain based upon your numbers here, and then go for it, okay? All right, and you guys get to try the backside, okay? So go ahead and turn it over and get to work, and obviously work together and check your work with each other. All right, check your work with your group. All right, and do yourself a good job here. I'll send out the key later. You know me, I always do that. All right, and make yourself proud, and I'll see you in my next lesson when I get back. All right, so this is, once again, this is Unit 2, Section 3. It's Section 5.3 in your textbook. If you want more examples, read your book and check out Section 5.3. All right, this is Mr. Ainsworth. I'll see you guys later in my next lesson. Bye-bye.